Let's start. In this session, we are going to discuss virtual warehouse in Snowflake. What are virtual warehouses in Snowflake? Okay. What are key features of virtual warehouse in Snowflake? Then common use cases of virtual warehouse. And then we are going to see how to create, start, stop, resume, suspend, and drop virtual warehouses in Snowflake. Okay, these are step by step. We are going to discuss virtual warehouses in Snowflake team. Yeah, let's start first understanding virtual warehouse in Snowflake team. Let's say this is my Snowflake. Snowflake in Snowflake in Snowflake. Snowflake is separated storage separately and processing separately. Processing units separately. Generic term is processing. Virtual warehouse terminology is sorry. Snowflake terminology is virtual warehouse. Virtual warehouse. Virtual warehouse. Okay. So we have two important Snowflake separates both storage and processing. This processing in Snowflake terminology, we call it as virtual warehouse. Virtual warehouse plays very important role in Snowflake. Let me add one more point here. Here we have small data, let's say 2 GB data. Let's say we have medium data, let's say 20 GB data, 20 GB data. We have big data, let's say, uh, 100 GB data, 100 GB data. In traditional architecture, in traditional architecture, how it look like, how it look like, both storage and processing in same machine, storage and processing in same machine. Let's say this is worker machine. This worker machine contain storage. This worker machine contain processing units. But Snowflake is a cloud data warehouse. It separates storage separately and processing separately. This processing we are calling virtual warehouse. What is the advantage of this virtual warehouse? Here, you no need say I have 1 GB data, use only these many missions. I have 20 GB data, use these many missions. I have 100 GB data, use these many missions. We do not have a chance or choice in traditional architecture. But coming to Snowflake, using this virtual warehouse concept, we can create different sizes of virtual warehouse. I want two missions, two processors. I want four missions, four EC2 missions. I want eight EC2 missions. I want 16 EC2 missions. I want 32 EC2 missions. Like this, you can create multiple missions in each virtual warehouse. For all sizes, instead of using 32 missions mission, you can go small size. This is more than enough. This size, this is more than enough. This size, this is more than enough to process the data. So while executing, you can choose a right virtual warehouse. Right virtual. warehouse. Snowflake people will not charge for creating a virtual warehouse. When that virtual warehouse used for your data processing, then only Snowflake people charges. Otherwise, they will not charge. If it is traditional architecture, whether you are using or not, you have already purchased those machines. You already purchased licensing for operating system, databases, etc. But here, virtual warehouse charges based on the number of resources used at runtime and how long those resources was used. Okay, based on that, Snowflake people will calculate pricing. Next topic we are going to discuss after this one, we are going to discuss how Snowflake people calculate pricing for storage. How Snowflake people calculate pricing for processing. We are going to discuss clearly. Now let's understand key characteristics of virtual warehouse. Virtual warehouse means it is a compute layer in Snowflake. Don't think by seeing name warehouse. Warehouse usual terminology is storing the data. But here virtual warehouse is a concept of compute layer in Snowflake. So so it's a compute layer. And here remember one important point. If you use AWS for backend of your Snowflake, this virtual warehouse is easy to measure. If you use backend cloud AWS Azure for uh, Snowflake, then compute virtual warehouse we create using Azure VM service. If it is Google Cloud platform, then virtual warehouse we use Google Cloud Engine service. Okay. Next one. And independent of storage. It is nowhere related to storage. Storage part is different, processing part is different. Snowflake separates storage and processing. It our warehouse is independent of storage. Existed traditional architecture, both storage and processing in a same mission. Coming to scalability, very important one, scalability. Just now I said we can create different virtual warehouses based on the requirement. You can select a right virtual warehouse. So let's say I executed today's sales data with two resources. Tomorrow data is increased. Instead of two resources, you can scale, you can call four missions virtual warehouse. And after 1 month, my data is grown, not like anything. Then instead of four virtual resources, I may use 16, I may use 32 virtual warehouse. Okay, scalable across the load. Next one, auto suspend and auto resume. Auto suspend and auto resume. Let's say you created two virtual warehouse mission, four virtual warehouse mission, eight virtual warehouse mission, 16 missions virtual warehouse mission, etc. You created multiple. By default, by default, those are suspended. Means Snowflake people will not charge. Whenever you executed query and you chosen X warehouse, then that warehouse going to become active. Active. Virtual warehouse can be configured automatically suspend. By default, automatically it suspend. You no need to do manual so that Snowflake people will not cost that virtual warehouses. And they auto resume whenever you submit a query. Let's say You submitted query this time. Until 10 minutes you did not submit, then your virtual warehouse not going to in active mode. It is in, it is once execution is completed, it will wait a few seconds, then it will enter into auto suspend mode. Again after 10 minutes you executed one more query, then it will become active, auto resume. And multi-cluster warehouses, very important is multi-cluster warehouse. You can create multiple sizes of warehouses. One warehouse with two resources, one warehouse with four resources, one warehouse with eight resources, one warehouse with 16 resources. Like that, you can create multi-cluster warehouses. Snowflake people will not charge for every Snowflake warehouse. When that warehouse is used for processing, then only they will calculate. Billing. Billing, they calculate in the form of credits. Billing, they calculate in the form of credits. I said, I said one important point is, even though you created multi-cluster warehouses, Snowflake people will not calculate pricing for every warehouse until unless the warehouse is used for query processing. If warehouse is used for query processing, then Snowflake people generate a billing in the form of credits. What is credit price in Indian rupee? We will discuss in uh, warehouse pricing part. Okay. Next one, common use cases of virtual warehouse. Just now we discussed, I have a small data, I can use less resources warehouse. I have a medium data, I can use medium sized virtual warehouse. I have large data, I can use big cluster warehouse. So based on your use case, you can select a right warehouse to process your data. And next one, query execution team. Query execution, running SQL queries are workloads. Next one, data loading, unloading. Sometimes we may load data from cloud warehouse to cloud data lake to Snowflake. Sometimes we may have a requirement unloading data from Snowflake to cloud data warehouses. Here, which is going to process these queries? Virtual warehouses and transformations. Let's say I have raw data. On that raw data, I want to implement city-wise sales. Then processing, we have only one technique. Who is going to process in Snowflake environment? Virtual warehouse. Now let's start understanding how to create virtual warehouse, how to stop, how to resume, how to suspend and drop virtual warehouse in different approaches. Using command, using graphical approach, using graphical approach. Okay, let me explain. So first one thing, open your Snowflake web UI, Snowflake web UI. So this is my Snowflake web UI. Here, here you can see, let's say here, default virtual warehouse. Default virtual warehouse. You can see compute underscore WH. size is x small, x hyphen small. So default when you create a Snowflake account, Snowflake people will create one virtual warehouse called compute underscore WH is, and this is x hyphen small, x hyphen small. We have different uh, plans team. We are going to discuss those plans with pricing, warehouse pricing. Just understand x hyphen small means it is a two resources mission, two sources cluster. Next one. So by default, whenever create, it will create a virtual warehouse for you. I'm not happy with the size of default warehouse. I want to create I want to create my own virtual warehouse. You can use this command. You can use this command, say uh, create or replace, create or replace warehouse, create or replace warehouse. Warehouse name is my underscore warehouse one with warehouse size x hyphen small means two resources. Auto suspend 120 seconds. Auto resume true and initially suspend to. When you create your virtual warehouse, do you want to suspend initially? Yes. Auto suspend after 120 seconds means I executed one SQL query, but until 120 seconds I did not execute any SQL query. Then make my virtual machine in suspend mode. When I execute any query, I'm saying auto suspend, auto resume true. Okay, let me select this command. Let's execute. See, warehouse is created. Then here you can press this one. You can see my warehouse underscore one. You can select this one. From now onwards, it is going to use my underscore virtual warehouse. You change a different warehouse, it will choose that warehouse. Whatever the warehouse we choose, it uses that warehouse to process your queries. Next one. Understand here? Understand here how to drop a virtual warehouse. How to drop a virtual warehouse. You can go with this command. You can say drop warehouse, my warehouse one, my warehouse one. Select this one. You can run this query. You can say my warehouse is successfully dropped. You can go here. You can see, you cannot see my warehouse. Let's refresh. You cannot see my warehouse. You can see only compute underscore WH warehouse. Next one. This is command interface. I want to create graphically. Instead of writing command, I want to create graphic. Let's say here you can see uh, you can click on warehouses. See, already presented different warehouses. Here you have a option called warehouse. Click on warehouse, give a name, my underscore warehouse 2. Then see here, you can see type. Standard is recommended. We have different standard Gen 1 and optimized one. Standard Gen 2 is recommended. Here you can see sizes. X hyphen small, small, medium, large, X large, 2X large, 4X large, 3X large, 4X large. We have different sizes. Size selected X hyphen small. These are two important in that name of virtual machine is one important, size is another important, and additionally we have advanced options. Auto resume. In command prompt we provided auto resume true, auto suspend true, right? And auto suspend when you want to suspend. There I give 120 seconds. Sorry, here 5 minutes. There I give seconds. You can select minutes also. Mm. Then click on create a warehouse. So go to our query, go to our query, sorry, editor. Okay, here you can select our my warehouse too. One, we can go with command prompt for creating a virtual warehouse. Second one, graphical, we can go and start with our virtual warehouse. Is it clear, Tim? What is virtual warehouse and how to create virtual warehouse? Yeah. So in this session, as part of Master Snowflake, we are discussing Snowflake virtual warehouse pricing. So we can create virtual warehouse using compute virtual warehouse. While creating virtual warehouse, we can see different sizes. Here we can see different sizes. Yes or no? Let me discuss these sizes with the pricing. Okay. And we are going to discuss with the different use cases. Let's start understanding it. So first one, if you see here, if you see here, you can see select size X hyphen small, small, medium, large, X large, 2X large, 3X large, 4X large, right? So excess, one credit to one credit per hour. You may see dollars or some other pricing model in different cloud environments, right? Similar way, in in Snowflake, in Snowflake, they call it as credits. Later, each credit is converted into dollar. So first understand credit. If you select size XS, XS, here XS means it is one credit per hour. Okay. Next one, small. If you select cluster size small, if you select cluster access only one mission. If you select small, you will see two missions in a cluster. If you select medium, four missions in a cluster. If you select large, then eight missions in a cluster. If you select Excel, 16 missions in a cluster. If you select 2XL, 32 missions in a cluster. If you select 3XL, 64 missions. If you select 4XL, 128 missions. 5XL, 256 missions. 6XL, 512 missions. 512 missions. Here it is given 4x means 128 missions. 128 missions. We have also different sizes. All clouds not supports all these sizes team. If you select AWS, it may support 6XL. If you select Azure, it may support 4XL. If you check GCP, it may support 5XL max. Okay. So size we can select. Let's say, let's say this is my snowflake, snowflake. Here I have the data. Here I have the data. Then I executed this select query, select query on this data, okay, I executed select query on this data. I used XS virtual warehouses XS. It contained only one resource. So if you submit select query, this query going to process, and it is taken 1 hour to process this data. Per 1 hour, they are going to charge only 1 credit. Per hour charges 1 credit. If you use two missions less than or equal to 1 hour, it takes what? 2 credits. If you use 4 missions, it reduces time, right? Then it uses, if you run your query less than or equal to 1 hour, they are going to charge 4 credits. Okay. So similar way, different sizes with different credits. Now let's understand what is credit, how credits are calculated. Let's take different use cases. How credits are calculated for user managed virtual warehouses. These are depends upon size, number of cluster. Yeah, yes, correct. Hmm. Hmm. Correct. Yeah, correct. That's what I'm saying. If you use number of clusters based on the size, number of clusters, and time. These are three factors to calculate the pricing. Correct. You are correct. We are discussing that point here. Yeah. Let me add how Snowflake going to calculate billing for your query running into Snowflake called credits. Let's setting. This is my Snowflake. This is my Snowflake. And here I have data. I have a data. Okay. To run this data, I'm using virtual warehouses. I created multiple virtual warehouses. So here runtime is 6 seconds. 6 seconds. This data I used X warehouse to process. But it is taken only 6 seconds to process, but still charges 60 seconds. Means for 1 minute to charge. Even though the query is executed within 6 seconds, less than 60 seconds, but how billing is generated for 60 seconds means for 1 minute charge. If your query taken 65 seconds, then they are going to charges 65 seconds. Another scenario, 1 second is executed, then paused again 30 seconds. Just said, paused, and after some time it is executed 30 seconds only. For this one, 60 seconds is calculated. For this one, 60 seconds is calculated. Total is 120 seconds billing. Next one, 60 seconds continued. Then after that, paused. 1 second is continued. Paused. 30 seconds continued. 60 plus 60 plus 60. 180 seconds. Start. Paused. Resume. Some minutes. And then paused and continued. So total 180 seconds billing going to generate. Next one. 1 second start, then paused, 20 seconds continued, paused, 68 seconds continued. 60 seconds plus 60 seconds plus 68 seconds. 188 seconds. 120 plus 68. 188 seconds billing going to generated. That's what we have to careful while running queries. Start, don't put pause. Then that pause also calculated less than or equal to 60 seconds call 1 minute billing. 1 minute billing. You just started virtual machine. Immediately you paused 1 second. Then they calculate what? 60 seconds calculation. Means 1 minute billing calculation. So time plays very, very important role in calculating billing. Second factor is number of clusters. You may create multiple virtual warehouses with different sizes. Then how many clusters you are using to process your query? One of our friends said he has a good amount of data. To process that good amount of data with less time, you want to use multi-cluster. Yes, you can use for improving performance of your query. But but they calculate pricing, and that too these kind of time. One cluster taken 6 seconds, another cluster taken 60 seconds, another cluster taken 30 seconds. Final billing is 180 seconds. Yes or no? So billing also calculated based on time plus number of clusters included to process your data. And finally size. Let me go to scenario use case. I'm going to show you one scenario. Let's say in this scenario, first 1 hour, first 1 hour, single small warehouse is involved. First 1 hour. And second hour, two mission means small. Small means two missions virtual warehouse. Two missions virtual warehouse. Excess means single mission. So here single small warehouse means two resources to process this one. Okay. First 1 hour small mission used means two resources. Total credits are two. Second hour Second hour, small instance is used, small warehouse is used. Again, two credits. So, two credits. Total resources used is 4. Total credits are 4. Okay. Scenario 2. Small size multi-cluster. Small size multi-cluster warehouse with 3 warehouses. Here, small size single cluster but running 2 hours. So I want to reduce this time. I want to improve performance. What I'm doing? Small size multi-cluster with 3 warehouses, virtual warehouses. First hour, I used small size warehouse. Okay. And warehouse 2. So 2 plus 2, 4 credits. Warehouse 3, I used in first hour. Total credits are 6. Second hour, warehouse 1 is used, warehouse 2 is used, warehouse 3 used. So total is 6 hours. Total warehouse resources are 4, warehouse 2 are 4, warehouse 3 are 4. 4 plus 4, 12 resources, 12 credits is generated. Yeah, now let's see use case to run auto scale 2 hours. Instead of using 3 hours, we enabled auto scaling. Let me show here. Let me show here. Here we have advanced options. Advanced options. See, in advanced options, we have suspend, multi-cluster warehouse, query accelerator, auto suspend, then type. Here we can see standard. We added multiple. Then observe here what we are doing. Run mode is auto scale 2 hours. Auto scale 2 hours. Instead of using three warehouses parallelly, I enabled auto scaling. I said minimum 1 warehouse, maximum 3 warehouses. Maximum 3 warehouses. Okay. So first warehouse is continuously running 2 hours. Second warehouse is continuously run only 1 hour. Only 1 hour. Warehouse 3 runs only 30 minutes in second hour. Second hour. So first warehouse continuously running first hour, second hour. So total hours are 4 hours. 4 hours means 4 credits. 4 credits. So first hour 2 credits, second hour 2 credits, and second hour warehouse 2 runs continuously from first hour to second hour. First hour to second. Okay. Warehouse 2 running in first hour. First hour continuously runs only 1 hour, that to second hour. It started in second hour. First hour 0. In second hour it is started but ran only 1 hour, means 1 credit. Coming to third one, started in second hour, third one started in second hour but ran only 30 minutes. So less than or equal to 1 less than or equal to 60 minutes, then they calculated 1 credit. Let me discuss it. We have warehouse 1. Yeah. You can create a multi-cluster warehouse. So are you getting point to it? Let's say we configured 3 virtual warehouses with small, with small. Small means what? 2 resources. Small means what? 2 resources. So I created warehouse 1, warehouse 2, warehouse 3. So first warehouse running continuously 2 hours. First hour it used 2 resources. Second hour it used 2 resources. So 2 credits, 2 credits. Warehouse 2 continuously ran only 1 hour, that too second hour. Second hour warehouse 2 is used, means 2 resources utilized. Coming to warehouse 3 ran only 30 minutes, that too it is in second hour. It is in second hour. Ran for 30 minutes in second hour. First hour 0, second hour it ran 30 minutes means 1 credit. 1 credit. So total credits are first warehouse is 4, second warehouse is 2, third warehouse is 1. Total credits are 7 credits. So we can create a multi-cluster with resize. So here we have a option while creating warehouse, we can add different properties. If we add resize, if we add resize, and if our application is running with multiple warehouses, if application is running more than 1 hour 30 minutes, we are doing resizing. We are asking Snowflake to resize. If you select this resize, then you can modify small to medium or small to large or X large, 2X large. Like that, you can modify to improve performance of your queries. You can create a multi-cluster warehouse with these kind of additional properties. Okay, clear, right? We give a properties here. Here we give resize property in warehouse creation. Resize property. Resize option. Resize equal to medium. Sorry, here already it is a medium. Then you can say resize equal to large. Resize. Resize. Yeah, correct. If load is increased or load based or time based. In this scenario, we are saying time based. If your query running, if your query running more than 1 hour 30 minutes, then resize small to medium. Correct, correct. Auto scale, no, auto scale enabled for query. You are correct. Query to query, these scaling features are applied. Yeah, you created a multi-cluster. You created a multi-cluster. Multi-cluster name is Sreenivas. Sreenivas. Multi-cluster name is Sreenivas. You put all these in that feature. Then first query less than 1 hour only. It ran less than 1 hour. Then it uses only warehouse 1 because warehouse 2 starts if query runs 2 hours. Otherwise, it will not start warehouse 2. Getting point? Runs continuously from second hour. Warehouse 3 runs only last third hour, that is within 15 minutes. If still your query running, 3 hours, and that too 2 hours 45 minutes, then warehouse 3 starts. medium credits applied. Yeah. That's it for today too. Tomorrow we are going to discuss storage pricing. And once again, if you get a query and we'll discuss this virtual warehouse query, then we will continue storage pricing in tomorrow class. Let me prepare these kind of multi-cluster query for each scenario so that you will get a clear understanding. Okay. Yeah. Yeah. Let's start it. So in this session, as a part of Master Snowflake, in this session, we are going to discuss Snowflake storage pricing. How Snowflake people calculates storage pricing. So we seen uh, virtual warehouse pricing. How Snowflake people calculates virtual warehouse pricing. So they charge in the form of credits, and number of credits depends upon size and number of warehouses active per hour. Size of warehouse and number of warehouses means a cluster per hour. And it also depends upon cloud vendor. It also depends upon cloud vendor because vendor to vendor, vendor to vendor, this virtual warehouse cost may be differ. Example, AWS, we use which service for virtual warehouse? Which service we use for warehouse, virtual warehouse? EC2, EC2. And AWS, Azure, which service we use for virtual warehouse? Azure VM, Azure VM service. From GCP, from Google Cloud Platform, we use Google Cloud Engine service. Google Cloud Engine service. Okay. So here, uh, it depends upon this warehouse size also depends upon cloud vendor, cloud vendor, vendor to vendor, service cost may be differ. Next one, and it also depends upon region. Let's say Mumbai region may be less, US region may be cost because their data center cost is compared to India, US center cost is high. So that is one more important point while they calculating warehouse sizes. Uh, it is also very important point. Next one, edition. What are different editions available? Standard edition, business critical edition, enterprise, and virtual private Snowflake, right? And it depends upon the uh, edition also. Coming to storage, coming to this similar way, if it is AWS, if it is AWS, they are going to use S3 service for storage. If it is Azure, if it is Azure, they are going to use Azure blob file system for storage. If it is GCP, if it is GCP, and they are going to use Google Cloud Storage. Google Cloud Storage for for Snowflake storage. And storage cost also depends upon the vendor because S3 size, blob pricing, and Google Cloud Storage may be little difference, maybe minor data cents, but that sense is when we store huge volumes of data, then that sense also gives high pricing. Yes or no? So storage price first depends upon the cloud vendor. Next one, next important one, storage's pricing they charge in the form of dollar tip. Storage prices they charge in the form of dollar, not credits. They calculate in the form of dollar. And next one, here, one more important, it depends upon the columnar compressed storage is also considered. Columnar compressed storage is also considered. So backend, while storing table data, let's say you are using S3, if you use Parquet storage format and Snappy compression, gzip compression, we have different compression formats. That is also considered. Let's say if you store directly text format, then let's say 1 TB data. That is not compressed. So 1 TB data directly going to store. If you use compression technique, then at least 40 to 50% it is going to compress different compression technologies, at least 40. So data size may be reduced. So columnar and compressed storage is also considered. Next important one, yeah. And additional factor for storage cost is it also depends upon cloud vendor. So vendor to vendor, storage cost is different. AWS S3 storage cost, Azure Blob storage cost, and GCP cloud storage cost, cloud storage file system cost, little difference, and it also impact in region. If you select different region, let's say a country to country storage data center, and it affects that region also. And next, you can go with this URL. Let me open this URL. Uh, Snowflake dot pricing. Let me open this URL. Let me show you. Sorry, let me remove this one. You can see, uh, you can select a cloud vendor. Let's say AWS or Azure and GCP. You can select a region. Then you can see storage sizes, storage cost. If it is standard, if it is standard, what is the storage cost? And if it is enterprise, business critical, virtual private cloud, then if you select same thing, little little variation, see $2, and select region also. It impacts region also. Okay, so you can go with this URL. You can find storage cost in different vendors. So first important point to think, storage again, storage again impact on two parameter stream. on demand and capacity. On demand and capacity. Let me, so these two also impacts on storage. Let's say on demand tip. So pay per uses month to month. Yes. Today I used let's say TB. So $40 for TB. Then use case one, use case one actually used 0.25 TB per month. Then billing is 0.25 into this dollars. So we'll get, let's say, $10. This is on demand. How much you use, they pay only for that. Second use case, actually used 0.880 TB per month. Billing is 0.80 into 40 or 49. Then, no, we used this size of data. Let's say this is my storage S3. No, it's $40 type of mistake. Coming to here instead of on demand, I want to take a fixed size of capacity. Whether you use, but you have to pay complete money. So I taken a 1 TB plan. Assume, but here remember on demand price is little high. If you take a fixed size, pricing is little lesser. Let's say we bid storage cost, let's say TB, assume $23. Use case one, we used only 0.25 TB per month, but billing is $23. You used very less amount, but still you paid $23. Use case two, you used 0.880% TB per month, but still pricing is $23. Less than 1 TB you used, still you paid for $23. But here, best concept is same, values are assumptions. Just as my assumption, $40 assume per TB. But it depends upon here. Yes, correct. All three clouds. Hmm. Yeah. Let's start it. As part of Master Snowflake, in this session, we are going to discuss a very important topic, Snowflake time travel and Snowflake file save. And we are going to discuss with practical stream. Let's first understand Snowflake time travel. Let's say in Snowflake, let's say project one, we will create a database. Let's say for client level. Say ICICI client, ICICI client. I created DB1 and ICICI having different uh, projects. Let's say project one, assume schema one. Project one, schema one. project 1 related all ICICI project 1 related tables, all ICICI project 1 related tables. Let's say in this schema, we will create for all these tables, then we inserted data into this table. Like this, for other projects, project 1 and so on, project N. Similar way, other client 2, client 2. Assume, assume someone in our developer team, maybe junior developer or some other guy, he deleted a table. Assume deleted a table. A wrong typo, a table is deleted. Maybe using delete command or maybe using delete keyword pressed in uh, keyboard, or instead of deleting other table, you may written a command to delete. Instead of deleting X table, you may executed Y table deletion. Then how we can recover this deleted table? Deleted table. In Snowflake, we have a concept called time travel. Using let's see, time travel, time travel in Snowflake allows user to access historical data by querying. Next one, first we can access historical data by querying and restoring or cloning tables at a specific point in the past. Example, let's say this one deleted at 9:31 or 9:32. So specific point of time before 9:32. We have this table, right? So 9:31, we have a table. 9:31, we have a table. So we can access or we can clone or we can restore a table at specific point in the past. So Snowflake will maintain all the data. So deleted data, we can restore that deleted data using time travel concept. So this time travel concept available 90 days, up to 90 days in enterprise edition. For standard edition, we have only 1 day, and enterprise edition, we can see 90 days in enterprise version. If you do not want to 90 days, less than 90 days, and it is configurable. Default is 90 days. Retention period of deleted data presence in Snowflake in 90 days. So I want to restore that deleted table, or someone deleted entire schema, or someone deleted entire database. If we delete entire database contain schema related to multi-project. So we may have multiple schemas. A schema may having multiple tables. If we delete entire database, we lose everything. So to restore deleted data, it may be table, it may be schema, it may be database. We use a concept called time travel. To apply time travel, we have three important methods to restore deleted data. So we have three concepts. First one, offset. Second one, step. And third, query ID. Using offset or using timestamp or using query ID, we can restore data of a particular point of time. Okay, first let's start understanding query ID with the practically. Let's say I am creating one table, one database, RADB. Think we already created RADB. So RADB we already created. In RADB we already created a raw schema. Raw schema. Okay. So let me check table. First, let's check in raw schema, do we have a EMP table or not? Under tables, we have employees table. Let me create a table called EMP. Create or replace table EMP. These are two columns, and I am inserting two records. I am inserting two records. So create a table, table name EMP. Before that, select a database and select a schema. Then execute create table command first, and then execute this insert command. Then execute this insert command. So number of rows inserted is 1. Now I am executing select query to know how many records are presented in this table. So right now, how many records are presented in EMP table? Two records. Two records are presented. So one more important point, whenever you are executing query, you can see query details, and every query contain one unique ID. One unique ID. So this query ID also plays very important role when we restore the data type. Just I'm showing here every query having query ID. Later we are going to use this query ID to uh, use this query ID in uh, one of time travel technique. Okay. Now we created a table. Now let's start. Now let's start implementing method one called offset. So here, what I am doing, what I am doing, in method one, in method one, what I am doing, using technique called offset. Before discussing offset, first let's understand I am deleting employee record 2. So I am deleting employee ID number 2. When I delete, my EMP table contain only one record. Listen, it contain only one record. So I want to restore this deleted data. So what I'm doing, first I'm creating new table like EMP. I'm creating a new table like old table. Okay. Then, then let's say here I'm executing insert query into employee table. Select star from EMP. At this time, EMP table contain only one record, but what I'm saying at offset, offset, I'm saying minus 60 into 3. Let's say 60 into 1. Let's say 60 seconds back. Execute this one. Let's search only one record. Okay. Let's see 60 into 2, 120 second back. We can see two records. Let me execute this query. and insert the data into EMP2. Now I am executing select star from EMP2. See, EMP2 table, now it restored two records. This one is 60 seconds. Offset 60 seconds time, 60 into 2 means 120 seconds. At that time, we have two records. So that state we are getting using offset command or offset feature. 1 minute. So we seen offset, right? Now another technique is method to timestamp. Let me use method 2. Method 2 also look like same as method 1. So before that, first let me create or replace table employee with two records. Once again, I am creating this table. So I'm using create or replace. If table is already presented, it will create a table. Then I'm inserting two records. I'm inserting two records. Then I'm executing select command to show how many records are presented in EMP table. You can see two records are presented. I am deleting employee 2, employee ID 2. Now we have only one record into EMP table. Now, now I want to access data using timestamp technique. So what I'm doing, I am creating new table EMP2 same as EMP table. Now, if I execute EMP2 table right now, we have only just it copied schema, no records. Now, see timestamp, I'm using date add function and I'm passing minutes minus 2. 2 minutes back. 2 minutes back with I'm minusing with current to timestamp minus 2 minutes. With this timestamp, I want to record. First, before inserting, let's execute. Let's execute this query. See, uh, time travel data not available. Let's say -1. Then let's execute. Yeah, only one record. Let's say now let's execute -2. No, -3. Let's execute. Okay. Let's once again execute 1. Let's execute 2. Let's wait a few seconds. Let me execute once again. Well, let's execute employee 2 table. We do not have any data. Employee 1 table, we have at this point of time, we have only one record. Once again, execute this select query. Let's execute -1. Let's execute this one. Let's execute -3. Yeah, we have two records. 3 minutes back, we have two records. Then I am inserting this data into EMP2. Now I am selecting employee 2. Now we are able to see two records. Execute this select one. Oh, okay. Let me execute 4. 4. Let's execute this one. Let me take 2 minutes. Okay. Let's once again create this create and replace table. Okay. Let's insert 2 records. Let's insert 2 records. Then select the EMP table. We have 2 records. Then I am executing delete. And then now I am executing EMP, only 1 record. Now I am executing new table EMP2. And then I am executing EMP2 table select, no records. Then before inserting, I am executing this one. Let's wait a few seconds. Now you can see 2 records. Now let's execute insert. Then let's see select a star from EMP2. Okay. So timestamp is very important. So when we execute, right, if that time is come over, then we are missing this one. Let's see, 3. This time we may. So once we execute, right, we lose the data, but we have only same record is inserted. We are discussing time travel. As part of this one, we have completed method 1 using offset, method 2 timestamp. Now let's see method 3 query ID. And for this, first let's create a table. So create a rates table, employee table, and then insert records. I'm inserting 2 records. Then in this table, currently we have 2 records. 2 records. So I'm implementing method 3 using query ID. Okay. First, I am trying to delete a record, second record. So if I execute this employee table, currently I'm having only one record. I want to revoke deleted record. So what I'm doing, I am creating one new table like existed table. In new table, currently we do not have any records. So I want to get records from from existed data, same like existed data. Before executing this delete command, whatever data presented in this EMP table, I want to read the same data into new table. So here we are using third approach is query ID. Every query, we have a query ID. So first go to query ID. Go to query history. This one is delete from EMP where ID equal to 2. So this before this query. So this is query ID. Take this query ID. Before this query ID, whatever the data presented in table, we want to same data into our new table. So use query ID. Once we execute any query, you can find that query in query history. In query history, we can see all the queries. You can select a query. You can find the query ID. Then copy that query ID. You can put that query ID here. In select from employee before this statement, this query ID. Before this query, whatever the data presented in this table, select the data and then insert the data into employee to table. Let me execute this query. Control enter. Then select employee table 2. You can see 2 records are restored. So once we execute any query in Snowflake, every query having a query ID. So you can find query history from transactions. Sorry, monitoring. You can go with the query history. Then you can see list of queries. List of queries. Then you can select that query ID from clicking on that query. Let's say we executed this delete query. Click on this delete query. You can find the query ID and you can use that query ID in this selection process. Clearly, how to implement method 3 to get deleted data into Snowflake table. Now let's continue time travel and failsafe. Now let's understand Snowflake failsafe tip. What is Snowflake failsafe? So by default, time travel available with 90 days tip. Once you delete any, let's continue. Let's continue Snowflake failsafe feature. Yeah, we discussed time travel, right? What is time travel? If you delete any table, if you delete any records, if you delete entire schema, or if you delete entire database, we can restore this deleted data. We can restore this deleted data using time travel technique. This time travel available 90 days till 90 days. So after 90 days, you cannot revoke deleted data. So if you enable this file say, additionally, you will get 7 days additional benefit to revoke data. So if you use time travel plus failsafe, you will get 97 days. 97 days. So by default, deleted data is available only 90 days. Once 90 days is completed, you can revoke deleted data. Enable failsafe. Additionally, you will get 7 more days. Yeah. Now let's continue master Snowflake. In this, let's continue types of tables in Snowflake. We have 4 types of tables in Snowflake team. One is permanent table. Once you create a table in Snowflake, those are by default permanent tables. And we have other types is temporary tables and transient tables and external tables. So first, let's see permanent tables. Permanent tables are default tables in Snowflake. Once you create a table using create a table command, then this table is a permanent table. Let me create one table. I am creating sales data table. Let me create. So I'm creating table sales underscore data. So when you create any table, by default, this is a permanent table. By default, this table is permanent table. So what is the advantage of permanent table? If table is permanent, then These are used to store persistent data and included in the backup and recovery process via Snowflake's time travel. So if it is a permanent table, you will get a time travel with 90 days. Okay, let me insert data into this permanent table. So I'm inserting 3 records into this sales data team. Then let me select data from this table. So you can see 3 records are inserted. So the permanent table, advantage of this permanent table, you will get benefit of time travel with 90 days. If you delete any record, if you delete any record, you can restore that deleted data within this time travel period. And when we go this permanent table, use case of this permanent table, this is usual requirement thing. Usual requirement. If you want to store data permanently, then we go with this permanent tables. Storing business data, then we go with permanent tables. Example, sales data, customers data, transactions data. So these kind of tables, we go with permanent table technique. Second type of table is temporary tables. Temporary tables exist only for the duration of the session. Once we close session, once we restart the session, we cannot see these temporary tables. Temporary tables, we create keyword called temporary. Create temporary table and table name. This prefix is optional. We always give this prefix to identify whether table is temporary table or not. Let's say I am creating table, create a temporary table, temporary sales summary, and I'm selecting summary data from actual table, sales table. So I'm applying some calculation. I'm getting summary data and I'm storing that summary data into temporary table called temp underscore sales underscore summary. Let me create this temporary table. So table created successfully. Let's see the data inside this table. Let's see the data inside this table. Select star from this temporary table. So you can see 3 records are presented with summary of sales table. And then I'm inserting some record into this table. So I'm inserting 3 records into this table. So now let's check this table. So total 6 records into this table. So now the temp underscore sales summary table must exit in the session where you run this query. Once we close this session, then we cannot see this one. Let's say I am opening, I'm closing this one, then I'm opening new SQL file. Then here I am selecting database raw underscore DB. I'm selecting raw underscore schema. Then I'm trying to execute this query. Select star from temp underscore sales summary. So object temp underscore sales summary does not exist or not authorized. This database. Let's select this database. Let's select raw underscore schema. Select tables. See, there is no table called temp underscore sales. Let's select a public schema. In public schema, there are no tables. So once we close the session, we cannot access these temporary tables. Temporary tables are available within that session. Once we close session, we can see temporary tables. So it's testing. Say you're using calculations, you want to store that results temporarily until some time during that session. If you close that session, you do not want to see that tables. Then you go with the temporary table string. Let's say I am calculating on large table. Results I want to temporarily in particular table, and I do not want that result permanently. Just for temporary calculation only, temporary use. So such kind of tables we create in temp. Using temp keyword we will create, and once our execution is completed, then we store the temporary result into target tables, and we will close session. Once we close, we can lose that temporary tables data. So because of this temp table, right? Data is not going to store into Snowflake permanently. Because of that, we save what? Storage cost. Once we close session, this temporary table data going to lose. Once data is going to lose, Snowflake people never charge for the temporary tables. Only within that period, how much time the data is stored temporarily into storage, that time only they calculate. Once that tables are deleted, then those are not chargeable, because once you close session, then you cannot see temporary tables exist in storage. And next important one, transient table string. Transient tables are similar to permanent tables, but with no title and no file save period. It means if you delete any data from transient table, you cannot revoke that deleted data. Time travel concept is not applicable to transient tables. Let me create a table, then understand whether time travel is applicable to the transient tables or not. Using transient keyword, we can create transient table string. Let me create a transient table. So I am creating transient table. So create table, transient table, stage underscore data. Let's create this table. Then insert data into this transient table. So I'm inserting 3 records into this transient table. Then then I'm trying to delete a record from this table. Let's say delete a table. Delete from table. Table name is stage underscore data, where product ID equal to 103. Before that, let's print table data. Select star from stage underscore data. So it is showing 3 records. I'm deleting 1 record. Let me implement query ID technique. Let's implement this third approach. Let's say I am creating second table. Let's say stage underscore data to like stage underscore data table. So it is created. I'm displaying stage underscore to data. Then I am inserting this stage underscore to data table by selecting stage table before deleting. Let's go to query history. So click on this delete stage table and select this query ID and use this method 3 approach to get the data. So currently in this stage 2 table, there are no records, and I am trying to implement time travel method 3 using query ID to revoke data. So I'm implementing this one. Then I am trying to print this table. You can see 3 records are generated. So see, we deleted this stage table data. This is 103 product. And let me select whether this record is deleted or not. Yes, because product 3 data is deleted. And check whether this table is created with the transient. Yeah, usually we go for this transient table for staging and temporary data, because during this ETL process, we implement transformations on raw data. We implement transformations on raw data, transformations on raw data, and we store this results temporarily into stage tables. Stage tables. So we validate these tables, we verify these tables, whether this transformation executed successfully or not. And once we apply transformation, data generated as expected or not. So to validate such kind of results, we store temporarily data into staging area. Once we validate successfully, then we move this data into target tables. Target tables. So these are these tables. These tables. Transient tables or stage tables are just for uh, verifying whether results are generated as expected or not. These are not for permanent purpose. Once we validate data is generated as expected, then we move the data into target tables. So if you apply any delete operation, we do not need this time travel. It means no need of maintaining deleted information. So that's why we go with transient to table stream. Yeah. Let's continue. Fourth important type is external table stream. So external tables allow you to query data stored in external stages, such as Amazon S3, Google Cloud Storage, or Azure Blob Storage, without loading into Snowflake. So data is presented in any of these locations, let's say S3 or Google Cloud Storage, Google Cloud Storage, or Azure Blob. Let's say in this we have data. In these locations we have data type. So our requirement is I want to run queries on this data. I want to run queries on this data before moving this data to Snowflake table. Snowflake tables. If I run any queries, SQL queries on this data, how we can run queries on this data is we have a concept called external tables. We can create external table. This external table points to external storage. External storage. Then I can run SQL query. If I find required data is presented, then I can copy this data to Snowflake table. So what is the advantage of external table is external tables allow you to query data stored in external stages. So external stage we can create with any of these cloud storages. It may be Amazon S3 or Google Cloud Storage or Azure Blob Storage. Without loading this data in Snowflake, we can write queries on this external data. So there is a concept called external stage. We can create an external stage to point to external storage locations. Once you create external stage, you can write Snowflake SQL queries on external stage to query data. Let's say I am reading sales data which is presented in S3. I am looking particular state related sales. I can write select query, select star from sales where state equal to Hyderabad. If no data presented in S3, then I do not want to move to Snowflake. So before moving this external stage, I can write query on this external stages using external tables technique. External table we can create on external stages. Once you create a table, you can write queries. If you write query, that query is going to execute on external stages. Data is presented in external stage locations. Example, let me explain clearly. So first important point, let's say we have external storage, external storage. It may be S3, it may be Azure Blob, it may be Google Cloud Storage. Google Cloud Storage. Here we have a bucket, and in the bucket we have a folder. Inside a folder we have file. Let's say these are CSV files. And let's say this is sales related. And in Snowflake, we have equivalent table. Let's say sales table. In this, we want to load the data. We want to load this data into sales table. So to load this data into sales table, we have stages concept. Stages. So we can create external stage, external stage, external stage to point to external file location. So this is stage concept from Snowflake. We can create an external stage which points to external file location. It may be S3, it may be Azure Blob, it may be Google Cloud Storage. Once you created this stage, you can write SQL queries. We can write SQL queries. External tables allow you to write query data in data stored in external stages. In these stages, this stage pointing to external storage. Then on this stage, you can write SQL query. Let's say you are writing one filter query. Let's say it's satisfied. Then you can write, you can move this data, you can copy this data to sales table. Such kind of validations you want to implement. Then create an external stage, write a filter query. If you find data is presented, then you can move external stage data to actual permanent table. Okay. Let me discuss time travel and file availability, different types of Snowflake tables. Permanent tables, time travel table, that is 90s. And additionally, file safe also available with 7 days. Transient tables, only 1 day, 0 to 1 day time travel is available. File safe concept is not available. So transient takes 0 to 1 day, 0 to 1 day time travel is available. Because of this, we are able to execute in base query on transient table. We applied uh, time travel technique. Because of that, we revoked data. Yes or no? So next one, for temporary tables, for temporary tables, time travel is not available. File safe is not available. For external table, time travel concept is not available because stage is data is not moved from stage to Snowflake table. Once data move to Snowflake external stage location to Snowflake table, then time travel concept is applicable. Clear writing, types of tables. Yeah. Let's continue. As part of Master Snowflake, in this session, we are going to discuss stages in Snowflake. What are stages? And we are going to discuss types of stages in Snowflake with the practical examples too. Let's say this is my Snowflake. Snowflake. Let's say for Snowflake backend, I used AWS. Assume I used AWS. If I use AWS, storage part is S3 service and processing part is EC2, right? Yes or no? Tip? So processing part is EC2. Let's say I want to load the data into Snowflake table. Load data. Let's say different sources. From different sources, from different sources, I want to load the data into Snowflake table. Snowflake table, nothing but S3 location. Yes or no? So in this location, it will load data. So if you are loading data into Snowflake table, it uses concept called stages. So before loading data into Snowflake tables, it uses concept called storage location. A stage in a Snowflake but storage for the data files before they are loading into tables. So Snowflake supports two types of stages, internal stage and external stage. Internal stage means within the Snowflake. External stage means it may be any cloud file system. Currently, it is supporting three cloud file systems: AWS S3, Google Cloud, and Microsoft Azure Blob. So, what is the advantage of this stage? So, before loading the data into Snowflake, if you want to perform any validation, then you can write a SQL query on stage data. Then you can validate. If data is valid, then you can move into Snowflake tables. So these stages can be either internal or external. If it is external, it uses cloud storages like Amazon S3, Google Cloud Storage, Microsoft Azure Blob. So we have two types of stages: internal stage and external stage. Let's understand internal stage. Internal stage. Let's say these are file systems. File systems are sources. Sources. Let's say there are files called sales files, sales.csv or JSON or Parquet or XML. And here I have to load this same data into EMP table, or sorry, sales table in Snowflake. So this is my requirement. So these are local files. Before moving these files to tables, we use stages. Let's say we have two types of stages, internal stage and external stage. So if it is internal stages are managed within the Snowflake ecosystem, means Snowflake warehouse environment. So first we will create a internal stage. Then we move this data to internal stage first. Then from internal stage, we use copy command and we move this data from internal stage to table. Internal stage to table. For internal stages, do not require any additional storage configuration. Whatever storage we use, right? Whatever storage used for Snowflake, right? It uses the same storage for internal stage. Coming to external stage, these stages are linked with external cloud storages like AWS S3, Azure Blob, Google Cloud Storage. Example, this is my Snowflake sales table. Snowflake sales table, and we have data in external clouds. So data may be presented in S3 or Azure Blob, or GCP Cloud Storage. Let's say we have data files. These data files, we want to load it into sales table in Snowflake. Then we get a external stage first. External stage. So these files are moved to external stage first. Then from that, we use a copy into command. Then we copy this external files into our tables. Before moving the data, we will create an external stage to point to external location. This external stage location may be any of these clouds. It may be Azure AWS S3, Azure Blob, or GCP Cloud Storage. Depends upon input, you create an external stage in corresponding. And once files are moved to external stage location, then we use a copy command. We move data external external stage to Snowflake tables. Yeah, I think someone is trying to ask question. Say, let's say we are loading local file, Snowflake. Let's say this is your Windows machine. In your Windows machine, you have data or Unix server or Linux or Unix server, you have data. You have data. You want to move this data to Snowflake table, Snowflake tables. Let's say here we create internal stage, internal stage, internal stage memory allocates in Snowflake storage location before directly moving into table. Let's say here I have a sales table, and this data related to sales files. And here, before moving data directly to table, first we move data to internal, internal stage. From this, we use a copy command. Then we copy this internal stage data to Snowflake table. If your data presented in your local machine, it may be Windows or Unix or Linux server, then we get an internal stage. Let's say you are moving cloud file system data. Let's say S3, we have data or Azure Blob, Azure Blob, we have data or GCP cloud storage, Google cloud storage, we have data. We have data. From this data we want to store it into Snowflake table. Snowflake table. Then here, let's say we are moving blob data to Snowflake table. Then here we will create a extra stage. We will create what? External stage. Then first we move data to external stage. Then our look like backend Azure AWS. So using copy command, we move data from external stage to table. So if you are in cloud file system data, we will get an external stage. If you are moving local file system data, we will create an internal stages. Yeah. Now let's continue states. In that, let's continue internal stages with example. We understand internal stage creates inside a Snowflake, and before moving data into Snowflake tables, first we will move data to internal stage. Then from internal stage, we copy in Snowflake tables. Here, internal stage, again we have three different types of it. One is table stage and user stage and name stage. So named stage refer with at the rate, user stage referred with at the rate tilde symbol, and table stage referred with at the rate and percentile symbol. Again this internal stage, divided into three types: table stage, user stage, and named stage. Okay, let's see practically this internal stage example. Let's say I have a file called emp.csv. Let me open local datasets location. In this, let's open Snowflake. I have emp.csv file. Let me open this emp.csv file. So this contains 11 rows, one header row. So total 11 records. Okay. So I am using this internal stage concept to move local file system into Snowflake table type. Okay. So first I'm user stage. User stage referred with at the rate tilde symbol. Table stage referred with at the rate percentile with a table name. Okay. So let's implement this one thing. User stage by default automatically available to each user. Means whenever you create a user in Snowflake, for every user space is by default available. So here, let's see, I'm using local file system. I'm using SnowSQL to move this data from local file system to Snowflake table. Let's say here, I'm opening SnowSQL command. We have already installed SnowSQL, right? Yeah. Yeah. So let's continue it. So in this example, what we are doing, we are moving local file system emp.csv into Snowflake table type. Snowflake table. So we are using SnowSQL to move data from local file system to Snowflake table. So for that, we are going to create internal stage. And remember one important point, once you create any user, every user automatically contain user stage. User stage we can identify or refer using at the rate till one. So first in your local machine, you can connect Snowflake with your username using SnowSQL command. SnowSQL -u, your identifier, -a, your identifier, then -u, your username, then press enter. It will ask a password. Let me show command prompt. In my command prompt, I entered SnowSQL -a, account identifier, -u, account username, then enter your password it enter into, it will connect to Snowflake. Okay. Once it is connected to Snowflake, then move your local file into user stage, @tilde/stage. So put command can be used to move your local file into user stage. Okay, I am using put command. Let me see under C drive, under C drive, under datasets folder, under datasets, there is another folder called Snowflake. Here I have emp.csv. This is my local file system. And local file system refer using file:3/. Local file system refer using file:3/, file path. Okay. Using put command, we are copying local file into user stage first. Let me execute this command. Press enter. See, one row emp.csv, target equal to emp.csv.gz, size of file 315 KB, target size, and source target and status is uploaded into user stage. User stage. Yeah, they have a logic of compression technique. It uses that inbuilt technique. We moved data from local file system to user stage in a Snowflake environment. And once we move, then we can use copy command. Copy command, we can copy this stage data into EMP table. From this stage location, you can copy into EMP table. Before that, let's check. Use raw_db. So we switch to raw_db. Use raw_db.raw_schema. We switched from public schema to raw_schema. Here you can see show tables. You can see all tables presented in this location. There is a table EMP. Let's see, select star from EMP. Only one record, and it contain only 2 columns, but my file contain different columns. So it contain 1, 2, 3, 4, 5. So first you need a table with the schema definition. So before copying the data, you need a table with this definition. So create a table. Tell me, create or replace table, table name, EMP, and table columns are, these are columns. Employee number, data type is int, employee name, string, and employee salary, float, gender, int, sorry, string, department number, int. So here choose database, raw underscore DB and raw underscore schema. Then let's execute this one. Let's use raw underscore DB dot underscore schema. Now let's execute this query. Now you can see select star from EMP. We have only table. There are no records. Now let's execute copy command. Let's execute copy command. Copy this stage data from stage data into EMP table. And additionally, we are giving file format is CSV, delimiter is comma, and it contains header, skip header. For copy command, we are giving all these instructions. Then press enter. Now it is copied. You can see 11 rows are copied. Now let's execute to select command. You can see 11 records are copied. So if you are copying local files, local files, we create a internal stage, and these internal stages, again we have three types of stages. One is user. For every user, we have user stage. It referred with with tilde symbol, and table stage. For every table, we have a table stage and a named stage. We can create one named stage manually. So these are three types of stages. So first example, local file we copied into user stage. From user stage, we copied into Snowflake table using copy command. This example is clear writing how to copy your local file into user stage and how we can copy from user stage to Snowflake table. To move from local file system to user stage, we use put command in SnowSQL. Then we move our local file system into user stage. From user stage to Snowflake table, use copy into command. And next one, table stage. Table stage. Let's say here every table contain table stage with a table name. Every table contains table stays with a table name. Then we can put our local file into table stays. From table stays, we can copy. Let me create another table. Let's say I'm creating creator replace emp2. I created another table. So here, using table stays emp2. So if you create a table, every table contains table stays. You can put your local file system into table stays. Then you can copy into let's see first let's display a two table data. Currently there are no records. Then I am copying this table data from table stage to table. Now execute select star from emp2. Now data moved from table stage to table location. Similar way, named internal stage we have to create manually using create command with the stage option. You can create a stage. Then you can move data from your local file system to named stage. Named stage. From named stage, you can move to table. Let's say I am creating one more table, emp3. Now let's execute select star from emp3. Currently there are no records. I am moving named stage to emp3 table. Using copy into command, I am copying named stage data to emp3 table. Now let's execute to select star from emp3. Now you can see records are copied. Clear writing, internal stages. Yeah, you can execute in same code in Snowflake. Yeah, let's starting. As part of Master Snowflake, in this session, we are going to discuss external stages. How to create an external stage to load data from external file system to Snowflake table. Okay. So let's see it. Let's say we have data in external file systems. It may be AWS, it may be Azure, it may be GCP. Assume we have a data in AWS S3. Under S3, we have a bucket. Under bucket, we have a folder. Under folder, we have, let's say, under folder, we have a file called emp.csv. To load this emp.csv file data into emp table of our Snowflake. So in Snowflake, what we are going to do, first we are going to create an external stage. Then we load this file data into our external stage. Before loading data directly into table, first we load the data into external stage. Using copy command, we are going to copy data into table. So if you want to access this file data, you need a IAM role. So we are going to create IAM role. Then we are going to attach this IAM role to access this process. So before copying, while creating external stage, we specify this IAM role details in our external stage so that our external stage having a access permission of S3 file. Okay, let's implement this one practically. Yeah, let's implement a practicality. First, step one, load the data from Amazon S3 bucket to Snowflake. This is our practical example. In this, first create a S3 bucket and upload the data. So I'm going to create a bucket, AWS S3-Snowflake demo. In that, I'm going to create a employees folder. In that folder, I'm going to place this file. Okay, let me open AWS management console and open AWS S3. So I am opening AWS S3 in a new tab. In this, I am going to create a bucket. So I am creating we already created a bucket, Sreenivas-Snowflake. Okay. In this, we already created a folder. In this, we already uploaded a file. While discussing AWS S3 for Snowflake, we already discussed this bucket creation process. We created folder, we uploaded file. Okay. Step one is already completed. Now, step two, create IAM policy. So go to IAM, go to policy and create a policy. So go to IAM, go to another service called IAM and open IAM in a new tab. Then here go to policy, policies. Here you can see create a policy, and this policy, let's see, create a policy and name Snowflake S3 policy. I am creating name is Snowflake S3 policy. So here you can see JSON and here you can click on JSON. In this JSON, we can provide this entry type. Take this entry. JSON entry. Then enter this JSON value here. JSON value. Observe here resource. Our Snowflake, sorry. This is our S3 bucket, right? This is our S3 bucket. And for this bucket, we are putting this bucket details here. See? So first copy resource number of your S3 location. Go to S3. You can find the resource number. Go to properties. go to properties. In this, you can find the resource number, Amazon resource name. So take this resource name, okay, and enter this resource details. Okay, in this, we have employees. In this employees folder, whatever the file we have, we want to access that one. Same, you can put resource number here, /employees. Okay, complete folder details we are adding in resource. And here we are giving policies. See, placing a file, getting the object, and deleting object. We are giving all these permissions on this file location, on this bucket location. So we are allowing listing objects of this file or folder or S3 bucket. Okay. Then once we provide all these permissions, then give a name. So I'm giving name is Snowflake S3 policy. Go to here, and here you can scroll down. Here you can click on next button, then give a policy name, then description also I'm giving the same name. Then here click create policy. Create policy. Okay, once we create policy, then create IAM role. So go to IAM role. So AWS-S3-IAM role. Go to roles. Go to roles and create a role. Role name is here. See, role we are creating. This role is for allowing AWS service like EC2, Lambda, other to perform actions in this account, or you can see custom policy, custom trust policy. Select this one. Here again, you can see in IAM role, let's say instead of custom trust policy, select AWS account. So allow entities in other AWS account, or let's say AWS S3, and select S3 service, S3 service. Then click on next button. Here select our Snowflake S3 policy, Snowflake S3 policy. Then click on next button. Then give a role name, AWS-S3 Snowflake role. Description also same. Then click on create a role. So role is AWS-S3 Snowflake role. And this is ARN of your role. Role ARN. This is my role ARN. Okay. Then go to Snowflake. Go to Snowflake. Create a storage integration. So this one. Create a storage integration. So I want to create a integration between my storage to this file location, right? So we are executing command to create a storage integration. Let's see here. We have a command called create or replace storage integration. and your integration name, and type is external stage, and provider is S3, and enabled true, and give a ARN of your role. So we created ARN, right? Provide that role ARN here. If any spaces, remove spaces, then give your file location. So S3 bucket location. So this is our bucket. Provide that bucket details. Okay. Now execute this command in our Snowflake. Go to Snowflake and then execute this storage integration command. Select this command, control enter. So you can see storage integration is created. So describe this storage integration tip. Describe this storage integration, control enter. You can see storage is enabled, boolean value true. Storage provider is S3, and storage location is this bucket with folder location. Okay. Next one, storage AWS ARN. This is storage AWS ARN, and this is role ARN and external ID. Okay. Now, copy external ID. Copy external ID. You can see external ID here. External ID. This is external ID. This is ID. Copy this ID. Copy this ID. Copy this external ID and copy ARN. Go to here. You can see ARN. You can see storage AWS IAM ARN. Copy this property value. Copy this property value. Then go to our AWS IAM. Go to AWS IAM. In this AWS IAM, we want to allow that external stage to access our S3. So for that one, you can see here, select a role, go to select your role. Then here you have a trust relation. Click on this trust relation. Here we need to update that details. Whatever details we copied here, right? We have to update these details too. So copy this external ID. Here you can see external ID. Copy this external ID and ARN. Let's remove this ARN. And whatever the ARN we copied, right? Here, go to Snowflake, copy this ARN, enter this ARN, and remove spaces here. Then take this value. Okay. Go to your IAM role. Go to IAM role. Just edit this security trust policy. Remove this one. Then place our uh, modified code. Then go to here, update policy. Update policy. Once we updated, then we have a integration between our Snowflake with AWS S3. Now I want to create a external stage. So here I am creating external stage to point to that file location. So where is our file? Our file is in this location. Copy this URL, then enter this URL here. So let's copy these bucket link. Copy this bucket link. In this bucket, we have employees folder. Let's go to execute this storage command. So I am creating this one here. I am creating a stage, external stage, create or replace stage, my S3 stage, and storage integration. I'm giving storage integration. So with this integration, external stage going to access S3 file system. Let's remove spaces here. Okay. Then let's execute this stage action. So stage is created. Once a stage is created, I want to know what are files and folders presented in this location. So for that one, we can execute a command. List command to know what is presented in that stage. If authentication is properly added, then we can show list of data presented in that location. Control enter. If everything is success, it gives a list of files. But here you can see, here we are getting error. AWS role user, this role is not authorized to perform resource to access this one. Let me go to role, go to permissions. Here we added this permission. Let me add attach policy. Let's try to attach S3 full access, attach permission. Once again, let's try to execute this command, list file. Still, our role do not have authorization permission to access the data. Let's go and check storage creation. We have a space here. Okay. Once again, external stage. Let's execute once again this one. And once again, execute to describe. Okay. Let's take this external ID, copy this external ID, go to AWS IAM, go to roles. This is our role. Go to trust relationship, edit trust policy, change this external ID. This external ID having a space. Let's remove this one. place this one, no spaces. Let's go again, copy ARN from Snowflake, copy storage AWS ARN, copy this one, then enter this ARN here, then click on update policy, and once again go to here, create a stage once again, then execute list of the stage, still same issue. Go to describe. Here we have two ARNs. See, storage ARN and other one role ARN. Let me take I am user ARN. Let's take copy this one. Let's enter this ARN under role. Go to edit trust policy. Let's change this ARN. Place here. Then click on use update policy. Go to Snowflake. Once again, then click list stage details. Still same issue. Let's check any spaces. Let's create a folder for until this bucket. Then create a stage. Okay. Let's scroll up. Let's check any step we missed, any spaces. Yeah. Let me create a storage integration up to bucket. Up to bucket. Then describe the storage integration. Then select external ID. Copy this external ID. Go to ARN. Edit trust policy. Just change this one. Okay, once again, go to here. Select user ARN. Copy this path. Then go to here. Change up to this path. Okay. Then click on save. Update policy. Then go to SQL. Create up to bucket path. And create a stage up to bucket path. Now let's go to list. Now we are able to see what is there inside this stage. So inside this stage, we can see a file, folder. Under folder, we can see a file. So we have to create up to bucket level, not until folder level. So we have to create external stage unto up to bucket level T. That's why we got issue of previous error. So now let's create a table and then in that table, let's insert employees file data. So create a table. Let's say, let me go to here. Let's go. So until we have employee 4 table, let's create a new table. So employee 5 table. Okay. Then let's execute this one. Create a table. Then let's employee 5 also presented. Let me create 6. 6 is created. Now let's copy data from external stage to this table. So copy into table EMP6 from this stage. Data copied successfully. Now let's write a select query. Select star from this table. Now we are able to see total records. Yes or no? So we have completed moving data from external uh, cloud location to Snowflake table using external stage concept. Let's say we want to automate this process. We want to automate this process. So we can automate using uh, multiple ways. One, Snowflake, we have a task. By creating a task, we can automate this process. Let's say every day we are getting file at particular time. So task should execute at that time and check file is existed or not, and then load the file into Snowflake table. Using task, we can automate or or if data is continuously generating in that bucket location. Instead of task, you can use a snowpipe. So, so to automate this process, we can go with the snowpipe. Snowpipe automatically executes when any object loaded into that bucket. If you create a snowpipe will read file, loaded file, and loads that file data into Snowflake table. We have multiple ways to automate this process. One is task, one is snowpipe. Snowpipe is snowpipe is also executes automatically when file is created into that bucket location. So snowpipe used for continuous streaming data. If data is continuously generating in that bucket location, best option is creating a snowpipe, automating the process so that when any new file is generated, our snowpipe going to connect that S3 location, reads the data and writes the data into Snowflake table. Yeah. Let's continue master Snowflake tip. In this session, let's discuss Snowpipe with a practical example. Let's see when we go with Snowpipe. Let's say, let's say in our S3 bucket location, data coming continuously, data coming continuously. Instead of manually running external stage concept, external stage to load the data, we can automate this process to load data from S3 location to Snowflake table. Example, inside a bucket, let's say files are generating. When file is created, our Snowpipe can connect that bucket location, reads and writes it into Snowflake table. Means instead of manually running at particular time to load the file from S3 bucket to Snowflake, we can automate this entire process using Snowpipe. Means if any stream is created in bucket, means stream means file or data is created into bucket, we want to capture that one, we want to write it into Snowflake table. So for this process, we can go with the Snowpipe. Snowpipe, it streams data from your input location to Snowflake table. So what Snowpipe going to do? When any event generated in this bucket, it will capture that event and loads it into external stage. Once it is loaded into external stage, we can execute the copy command. Then we can copy this data into Snowflake table. Okay, let's implement this process tip. So first one, we need to upload a files into bucket location. We need to upload data into bucket location. Let's say, let's create a file here, another bucket. Go to here, go to S3 location and go to buckets and create a bucket. So bucket name is this one, AWS S3 Snowflake demo2. Then uncheck this option, create I acknowledged, then create a bucket. Failed to create, maybe this bucket is existed with this name. So let me add Akkem Sreenivas hyphen AWS S3 Snowflake demo2. Let's create a bucket. So bucket is created. This is the bucket. Okay. In this bucket, we are going to load the file. Once we load, Snowpipe can connect to this location, reads the data. So for this process, I am automating. So create a IAM policy. We have already a separate policy. Let's create another policy. Go to IAM and go to policies and create a policy and go to JSON and take this JSON. Take this JSON and enter this JSON here. Remove this JSON and enter this JSON. Here we need to provide our ARN of S3 bucket. Go to properties and take this ARN, then enter this ARN. Similar way, enter this ARN here, bucket ARN. Okay, then click on next button, then give a name to this policy. I am giving policy name is this one, Snowflake S3 policy 2. This description also I am giving same thing. then create a policy. And after policy creation, let's create a IAM role. So AWS hyphen S3 hyphen Snowflake hyphen IAM role to tell meeting, go to roles, how to create it, go to roles, create a role, and then select this one is S3. Then click on next button. Then here you want Snowflake this policy to right. Select this policy to click on next button. Give a role name and description of role is optional. Then create a role. So role 2 is created. Role 2 is created. Now let's copy role of your ARN. This is ARN. Copy this ARN role. Then create a storage integration and provide this ARN. And remove this space. And next one, bucket name. Collect a bucket name here. So different bucket, right? Take this bucket name and change this bucket name. Remove space. Then create a storage integration. Go to Snowflake. Create a storage integration. Then describe the storage integration. Describe the storage integration. Then get external ID. External ID. Copy this external ID and change this external ID into JSON. Here, copy user ARN. Remove space here. Copy user ARN. This is user ARN. Copy this user ARN and change this user ARN. Then remove this space. Take this JSON. Go to role. Go to IAM role and go to trust policy. Edit trust policy. Remove this existed one and this our trust policy. Then click on update policy. Now go to Snowflake Snow site. Then create a stage. Create a stage and change this bucket name. Change this bucket name with stage command. Remove spaces. Then take this stage command, then execute to this stage creation. Then let's execute to here we have errors. Any space, yeah. Um, yeah, semicolon. Let's take this one. Once again, let's execute. Now list objects are presented in this stage. Currently, there are no objects presented. Just a bucket is presented. There is no data. Okay. Now create a snow pipe. Create a snow pipe to point our table. Let me create a table. Let's create a table called employee 6 or 7, right? Yeah. Create a table employee 7, employee 7. Then select star from this table. Select star from EMP7. There are no records right now. There are no records. Now what we are doing, we are going to copy data from that location to table. So what we are doing, we are creating a snow pipe. So let me load a file into this location, S3 location, S3 location. Let's load a file. Let's upload and go to add file and go to C drive, go to datasets, go to Snowflake and select this employees.csv and click on upload. Okay, then click on close. Then use copy command to load the data into this table using legacy previous command. So I am loading data using copy command to EMP7. So I'm loading data from stage to this table. So stage name is my stage, right? My S3 stage. Then execute select a command to display the records. Total 11 records are present. Okay. Now create a snow pipe. Now let's create a snow pipe too. So I'm creating create or replace pipe name EMP7 pipe, and then auto ingest to true. Means if any file is created in that location, then load execute this copy command. Just now we executed copy command using manual run, right? Instead of manual run, if any file is loaded into that location, then execute this snowpipe command and execute this copy command to copy the data into that location. So I am creating snowpipe. Let me create a snowpipe. So take this command. Let's execute this command. Okay. Now let's go to S3 location. Let me remove this file. Delete this file. So I'm going to create a new file and I'm going to upload the file. delete object. Now let me go to your datasets location. Go to C drive, go to datasets, go to Snowflake, and let's create another file. File name, let's say emps2. Let's open this file. Let's open this file and change employee ID string. So 1011, 1022, 1033, 1044, 1055, 1066, 1077, 1088, 1099, 100, 14444. Then save this one. Now let's upload this file into this location. Add a file. Then emps2 file I am uploading. Then click on upload. File is uploaded. I want to know whether Snowpipe is executed, loaded data into emp7 table or not. Just execute this select command. Execute this select command. You can see the result. Control enter. See, control enter. So we created Snowpipe 7. Auto ingest we said true. Then let me select this command. Let's say select count to star from emp7. Only 11 records. Let me check file is uploaded or not. It is uploaded. Let me upload one more time. Add file. Let's select this employees to. Then click on upload. Okay, once again, let's execute to this select query. So see, we created Snowpipe. Let me describe this Snowpipe. You will get ARN details. We have to update these details. Team. Let me describe this Snowpipe. Describe this Snowpipe. Sorry, EMP7 pipe. You will see definition of this one. You can see notification channel. This is notification channel. Okay. So notification channel, copy that to notification channel, copy this notification channel, copy this one, okay. So then uh, configure this event to notification in S3 bucket. So when file is uploaded, we want to call this stovepipe, right? Yes or no? So go to your S3 bucket. Go to S3 bucket. Let's remove, delete this file too. So let's delete this file. Delete this file. Okay. Click on delete object. Then we want to notify Snowpipe. A Snowpipe file is created. How we can notify Snowpipe? Go to this bucket. Go to properties. Here you can see bucket versioning, bucket ABS, and you can see different properties, encryption, and here you can see different options. Here cloud file events, and here create event to notification. Click on create event to notification, then event name. See, we have to fill these details. Event name is Snowpipe event, Snowpipe event. Okay. Then prefix is optional, suffix is optional. Event types. When file is loaded, called put event. Only put event. If you want any other, you can select those options. Event types. So select a event types and suffix is .csv. Prefix anything. Suffix is .csv. If CSV file created, then only notify my Snowpipe. Okay, here destination is SNS topic. Let's see here, you can see object creation and object removal, restore, ACL, tagging, reduce redundancy storage, life cycle, and here destination. Destination is SNS topic. And here SNS topic name. Choose SNS topic name. Choose from SNS topics or enter topic ARN. Okay. Then copy ARN from your Snowflake. Copy this ARN. Then enter this ARN here. Enter this ARN. Okay. Then click on Save Changes. Invalid ARN. You copied same ARN, right? Let me once again go to Snowflake. Snowflake. Copy this one. Okay. Go to here. Place here. Then click on Save Changes. It's saying invalid ARN. Let me go check spaces before here and after here. Then let's remove Save changes. Open ChatGPT. Last history showing invalid ERN for this one. Go to our S3 bucket. Sorry, here stages. Here we created snow pipe, right? Snow pipe. And here US East one. This is US East one, right? Based on this storage integration, it is created ERN for snow pipe. So it is created at ERN only. But still here we are getting error. Yeah. Let's continue master Snowflake team. In previous session, we started creating snow pipe with example. So we understand what is snow pipe, and we started implementing snow pipe. So we have created a S3 bucket, and we have created a policy, and we have created a role. Then we have copied ARN. Then coming to Snowflake side, we have created a storage integration. Let me open here. Let's see. We created a storage integration. We created storage integration. Then we created a stage. We created stage, and we updated IAM role trust policy, and we also created external stage, and then we listed data, and then we loaded data, and we loaded the data into Snowflake table. Now we created a snow pipe. Up to this part we have executed. Yes or no? And later we try to update this SNS ARN into Snowflake, AWS S3, uh, AWS S3 trigger. In AWS S3, we are trying to update this SNS link. Okay, SNS channel link. So let me go here. We created Snowpipe here. Let me see. This is Snowpipe. Let me execute to describe Snowpipe. And this is a Snowpipe. Here we have notification channel. This is notification channel. We copied this notification channel, and we are trying to update this notification channel into where? In AWS S3. Okay. Let me update this SNS channel. Go to S3 bucket and select the bucket. So this is second bucket, Snowflake Demo 2. In this bucket, you can see properties. In this properties, let's go to SNS. Let's update event. See, intelligent training, tiring. Here you can see create a configuration. Let's scroll down. You can see event notification. Here create event notification and give a event name. So provide these details to him. So give a event name. Let's say event name is Snowpipe event. And prefix is optional. Suffix is .csv files. If any .csv created in a bucket, then send a notification. Create event is called put event. And if you want any other, let's say post, then here you can see here SNS topic and enter SNS ARN. Select our ARN from here, from Snowflake, copy this notification channel, then enter this notification channel into S3 ARN. Place here, then click on Save Changes. So once again, go to Snowflake. Okay, let's create once again Snowpipe. Create or replace Snowpipe. Then once again describe the Snowpipe and go to notification channel. Copy this notification channel. Open in Notepad. Let's check, is there any spaces here? No spaces. Let's take this notification ID. Once again, let's enter here. Then click on Save Changes. Choose your SNS topics. Sorry. Enter SNS topic URL. So here in properties, here this is not SNS, this is SQS. So go to select event. Here what I did is, instead of SNS, I selected SQS and then enter SQS queue ARN, then enter ARN, then click on Save Changes. Okay. Now let's start. See, we created a pipe. Then if you go your datasets location, in datasets location under Snowflake, I created a new dataset with different values. So this one contain different data. I am going to load this file into S3 bucket. Go to S3 bucket, okay, click on close and go to bucket objects. Then just enter this file or load this file. Then click on upload. Then file is uploaded. Once file is uploaded, we selected put event, right? When put is generated, it will call our snowpipe. Snowpipe is executed. Then you are going to see this new data. Let's execute this select. Start from employee 7. You can see new data. Let me execute count. Control enter. So count is 11 records. Let's once again execute this one. Control enter. Yeah, you can see latest data. 10 1011, 1022, 1033, 1044. Latest records, it is updated. These latest records are updated. Now let's check a count. Control enter. See now 22 records. Now let's enter another file. Let's say 1112. Let's say other records. Let's say I want to enter records like 1 and 2, 3 and 4, 5, 6, 7. I'm changing other values 8, 9 and 10, 11. Okay, let's save this one and let's upload this file into S3 bucket. Let's remove this one, delete. Let's upload latest file here. Let's upload latest file, employees to. Then click on upload. So click on close. Then go to S3 Snowflake. Then execute count star. Let's wait a few seconds to execute to SnowPy. Once again, let's execute this one. It may take few seconds for updating. Let's execute count now. Let's execute to select. Let's go SnowSQL. Let's execute count. Let's check S3 file location. Bucket. It is uploaded. Let's refresh. Let's once again execute count star. Yeah, let me change this file name equal to employees3. Let's upload this file. Go to S3, go to upload, go to upload files and select this employees3 CSV file. Click on upload, click on close, click on close. Go to SnowSQL. Let's execute count star. Let's execute select star. Let's refresh. Now you can see new records are inserted. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, new records are inserted. Let's execute count. You can see 33 records. Okay, so it takes a few seconds time for updating data type. Once record is inserted, once file is uploaded into S3 bucket, Snowpipe will execute. Snowpipe will return this logic. Create or replace Snowpipe. Here, auto ingest true into this EMP7 table from this file, from this S3 stage. So this Snowpipe going to execute to stage and it loads a file from S3 location. Sorry, it will create ingestion integration with S3 with external stage. Then it will execute copy command. It will load that latest data into table. Okay. Clear writing, how to implement SnowPy. Yeah. Now let's continue master Snowflake. In this, let's continue zero copy cloning technique in Snowflake. So first important point, what is zero copy cloning? Zero copy cloning and how it will work. Snowflake allows instant creation of clones like databases, schemas, tables, and other objects. So you can clone a table or schema or database that saves same underlying storage. Only changes made is additional storage. Like let's say how it will work is usually when we create a clone, what happen? It uses same data in cloned location. But here, zero copy cloning technique uses same storage to clone the data. The benefits is instant copy creation. Cost effective is it uses same storage location. So you cannot get more extra charge. Using different ways, we can achieve this zero copy cloning using different techniques like CETAs, create as, like, clone methods. Let's see implementing these methods for creating clone of table, schema, and database team. So first I'm creating one sample database called sample DB, and I'm creating schema, sample schema. So I'm creating sample DB and I'm creating sample schema. Then I'm creating sample table. Then I'm inserting data into this sample table. Then I'm printing sample table data. Let me check, create a database. Sample underscore DB already available. It is created. Here I'm choosing sample DB and sample. Yeah, let me create sample schema. Then select sample DB. Sample schema is selected. Now let's create a sample table. Then insert records into sample table. Then I'm displaying sample table data. 4 records are created. I'm displaying describing sample table. Sample table contain only one column. Now I am applying CETAs, create as table. create as table to implement zero copy cloning. So create a table, sample table as create as a table from this existing table. So table is created. Then I'm selecting this new table. So total 4 records. Then see, first to describe sample table. See, column is ID. You can see other definition. You can describe create a table, create as a table definition, same column and data type. So we are creating table, sample table, sample table name. We are creating by selecting this table. Other approach to create new table is like a table. So if you see here, it is creating same schema, but storage location, it is going to connect this table. Yeah. Now let's continue next important topic in Snowflake team. Uh, Snowflake views team. Yeah. Uh, Let me understand the purpose of views. Let's understand introduction of views team. Let's say in Snowflake data warehouse, I have tables. Let's say a table called sales table. This sales table, let's say it contains 200 columns, 200 columns, and it contains millions of records, millions of records. So let's say on this table, downstream systems are preparing reports or dashboards. Let's say downstream like BI tools. These BI tools doing some uh, analytics on this sales data, and finally they are generating reports or dashboards. So here, instead of exposing complete data to downstreams, instead of exposing this 200 columns and these millions of records to downstreams, what we are going to do, we are going to create views. View, a view in a Snowflake is a logical representation of data. It is not a physical, it is a logical representation. It allows user to access and analyze data stored in the tables. Using views, we can expose few columns or few rows of a table. Instead of exposing complete data to downstreams, we can expose whatever they required. Let's say they want only 10 columns. They want only few million records. Instead of all records, they want only few million records. or they want only particular filtered data. So instead of exposing complete data to downstreams or users, we can create a views on a table. Then we can expose whatever they required. For that, there are different types of views team. First important one, standard view. Next important one, materialized view. Next important view is secure view. These are three types of views in Snowflake team. Understand first important one, standard view. Standard view is a virtual view defined by a query. This standard views does not have a data. If you print or if you select standard view and again internally it will connect to table to return the data. Standard view does not store any data. So standard view always depends upon the backend table. So to resolve this problem, they invented next important view called materialized view. Materialized view stores the query results. First time it does not have any data. Once we query view, then it will connect a backend table and first it will store that result into views. Second time onwards, it will not connect to table. It will directly return data from materialized views data storage. And third important view is called secure view team. Secure view provides enhanced security by handling underlying data from unauthorized users. So we can apply some security techniques for these views. So we can add authorization techniques to avoid unauthorized access from users. Let's start working and implementing these views team. So first let's start implementing standard views. Let me create a table. So I'm creating table called employees in this sample schema. So I'm creating table called employees. This employee table contain 4 columns: ID, name, department, and salary. Now I am inserting some records into this table. Let's say I'm inserting 4 records. I'm inserting 4 records into this table. Next, I am creating view on this table team. I am creating standard view. So create view and view name as we are writing select query on the table. In this, we are selecting only engineering department. So we are exposing only engineering department from this view. So whoever calls this view, they get only engineering department records. Let's say, sorry, let's create view. Create view, engineering employees as select query. So a view is created. Now I'm selecting this view. I'm writing select query star from this view. So if I write a select query, what happened? It is internally going to connect table by executing this select query. Because it is a standard view, this standard view does not store any data. It always depends upon backend table. Here, by writing select query, we are querying data on a view. Then backend again, it is going to run this select query, going to return data from backend table. Okay. So now let's start implementing materialized views. So materialized views, like a standard views, uh, we can create materialized views on tables. First time, it does not store any data. If anyone query on materialized view, it will connect to backend table, gets the data and stores the data into materialized views, and it occupies additional storage. And second time onwards, it will get data from materialized view location. Compared to standard views, materialized views executes faster. Let me create a materialized view. So to create a materialized view, we use one additional keyword called materialized view. Standard view, we use create view. Materialized view, we use create materialized view name as select query. Both are same, but only one difference. We use materialized keyword for creating a materialized views. Let me create materialized view. So materialized view is successfully created. Now let's write a select query on materialized view. So first time I'm writing select query on materialized view. Then it is going to trigger a query, select query on employees table and gets the data and stores the data inside materialized view. So second time onwards, it will not depend upon table. So it will return data directly from materialized view storage. So compared to standard view, materialized views are faster. If there is any changes in backend table, if there is any change in backend table, we have to refresh materialized view to get the latest changes. So we have to use this command alter materialized view name resume. So it refreshes the materialized view to keep updated data from table. Hmm. Yeah. Now we can use a task to you execute this alter command, or we can use task. We can add this SQL statement in task, and then we can refresh this one. Or we can write a separate SQL query. Then we can configure as a Airflow job. We do later. we will set a time. Let's say we, if any insert happens in X table, insert happens in X table, then insert or update or delete happens. We want to refresh our materialized view. So for this, we can configure task, or we can create a airflow diagram. Yes. So that's what we go, either task or airflow. Preferred one is airflow. Airflow will taken care to trigger this job. Let's say this alter query, this alter query, we write inside one SQL file, one XSQL file. We call this file using Airflow Java. Yep, that's what any updation, any deletion, any insertion happens on existed table. We want to refresh that changes into materialized view. For that, we are applying this alter query. Yeah, let's start it. In this session, we are going to discuss zero copy cloning in Snowflake. Okay. First, let's start understand what is zero copy cloning. Zero copy cloning is a Snowflake feature that allows you to create instant copies of databases, schemas, or tables without physical copying of the data. Without copying of the data, we can allow you to create instant copies of databases, schemas, or tables. The clone sets the same underlying storage as the original. So what happens here is no data duplication, no extra storage at creation time. Next, near instant operation. And next one, how zero copy technique or how zero copy cloning works internally. So here, let's discuss some important points here. Here, Snowflake uses metadata pointers. And next one, immutable micropartitions. And when you use cloning option, example, Snowflake copies own metadata. It will not copy actual data. Both original and clone point to the same blocks. Both original tables, cloned tables point to the same data blocks. When data changes, let's say if you inserted into cloned table, assume, then Snowflake creates a new micro partitions. There is a concept called micro partitions. It will create a new micro partitions. This is called copy and write. What are key benefits of this zero copy cloning? So first benefit is instant creation. Instant creation clone happens in seconds. Let's say you are creating a clone. So it will not take much time for creation. It will take instant creation of clone. Second, cost effective because both original table, cloned table shares the same storage. So, so it is cost effective and it is safe testing in production data without risk because I have a production data. I want to do cloning and I want to test. So it is a safe testing on production data without risk. Independent object changes do not affect original data. So to clone to clone database objects like Snowflake database objects, we can clone tables, we can clone schemas, we can clone databases, we can clone streams, we can clone tasks also. Okay, let's see step by step to implement cloning operation. So here we have different ways to implement cloning. So we have CETAs. CETA's full form is create as. Second one like. Third one cloning. Let's see difference between these three commands for implementing zero copy cloning technique. So first let's start implementing these three ways. So for that implementation, what I am doing, I am creating databases and then I am creating table and then I am inserting some data into this sample table. This one, let me open Snowflake. So let me write this create database script. So create database sample DB, create schema sample schema. I have already created sample DB. I have already created sample schema. This is sample schema. Then in that sample schema, I have created table called sample table, and then I have inserted some records. Let me execute this sample table, select query. So here change, switch from default database to sample DB, sample schema, use sample schema dot, sorry, sample database dot sample schema, switch to sample schema. Then let's execute. Let me open zero copy cloning workspace. Let's see, select this query, control enter, then database is switched and schema is switched. Now let's execute to select query. You can see total 4 records presented in this table. Now I am applying CTAS for creating clone operation. CTAS full form is create as. Using create as, I am creating a table. Using create as, I am creating a new table from existed table. So sample underscore table. From sample underscore table, I am creating sample underscore table underscore CTAS. Then I am displaying records. Select star from sample underscore table underscore CTAS. We are able to see 4 records. Yes or no? We are able to see 4 records. So we used which command? CTAS command for creating clone. Writing? Yeah. So here, if you use CTAS table, only table definition plus data, no key constants, no storage. So what does this one? It copies table definition thing. Let me execute select star from. Now let's execute describe a table, sample table, status. See here, we have one column and column data type and what is the type of this name and whether this allows null values or not. Before that, describe sample table. Describe sample table. You can see column name, data type. Then you can see it is a primary key. So while creating this table, we specified this table column is a primary key column. Right? Now let's describe our create as table. If you see, it copied column name, data type, means the same schema, but no primary key. It will not copy. So it copies table definition, it copies data, no key constraints. Now let's create another table using like. So I am creating new table using like command. Create a table, sample table like sample table. New table name is sample underscore table underscore like sample table. Let's create this table. Let's create a new table using like command from old table. So we already executed this command so that it is showing table is already created. Now let's execute select star from new table. So here no data and describe a table structure. If you use like command, it will copy entire structure including key constants, without data. See like command, it copies a table definition, no data, including key constants, no storage. No data means no storage. Now let's run clone command. Using clone command also, we can create a clone of a table. So I'm creating new table using clone command. Let's say create a table sample underscore table underscore clone using clone from existed table. Then select this cloned table. You can see 4 records are created. Then describe this clone table. So it copies schema definition, including key constants with the data. So table definition plus data plus constants, no storage. No storage means this clone points to same physical storage. New table and old table pointing to same old storage unless you do any changes in cloned table. If you perform any new insertion into cloned table, what happens? It will create a micro partitions record with new record. So when data changes in cloned table, Snowflake will create a new micro partition. Both original and clone pointing to the same data blocks. When you do data changes in cloned table, Snowflake creates a new micro partitions. Both original table and new table. Sure. Hmm. Yep, correct. Because yeah, virtual warehouse is not mandatory, but this virtual warehouse we can change depends upon data size. You can use different virtual warehouse with different size based on your data. Sure. Hmm. 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 Yeah, for entire data until unless you do not change in existed data, either old table logic or new table logic, both points into same storage. If you do any modification, it will create a new partition for entire data, for entire data. Yeah, sure. So S3, we have a bucket. Inside a bucket, let's say original table name is EMP. In this table, we have file, complete records with the files. So on this table, you created a cloned copy. For new table, let's say EMP underscore clone. This is new table. Both old table and new table pointing a same copy of data. If you do any modification, let's say you inserted new record, until you perform any modification, both pointing to same location. Once you insert anything, then it will copy here. Until that, both are pointing to same location. No, view we can use for exposing uh, only some columns or some rows of data. We can expose entire data also using view. Yeah, we can sync with the view. Yeah, let's continue. Uh, let's continue master Snowflake. In this, we are discussing views in Snowflake team. We have discussed standard views. We have discussed materialized views. Now let's discuss secure views team. So first important point about secure views is secure views are hide SQL logic and underlying tables, provide enhanced security and and required enhanced security are required for Snowflake data sharing team. So Snowflake secure views are views that hide the underlying SQL logic and base tables from users. Users can query the view but cannot see how it is built. Means they cannot know the query behind that view. User can query view. That's a tip. Secure views, secure views that hide the underlying SQL logic and hide base tables from users. What are benefits with secure views too? First important advantage is enhanced security. SQL logic and source tables are hidden from the users. And next one, protects business logic, means prevents reverse engineering. Next one, next important advantage is mandatory for data sharing. Secure views whenever you are sharing data. So these secure views are very, very important. Only secure views can be shared. And secure views supports joins and filters, same capabilities as standard views. In standard views, we can we can apply joins and filter conditions. Similar way, you can apply joins and filter conditions similar to standard views for secure views also. What is the main advantage? Works with masking. Let's say you want to apply row policies, enables row policies, then we can go with secure view stream. So simply we can say a secure view provides enhanced security by hiding the underlying data from unauthorized users. Users do not know about underlying SQL logic and do not know about base tables they built for this secure view. Let's see how to create a secure view. So we use create secure view name, and you can write SQL logic. Let me create a secure view. I am creating secure view. So here, let me select a database. Here I am selecting raw database and XYZ schematic. And in this we have these tables and views. So I am creating view, secure view, employee names as select name, department name from employees. Then create a secure view. So let me switch to database team. First, let's go to raw underscore DB and go to schema, raw underscore schema. We have employees table. Let's see. We have EMP table, no employee table. Let's check XYZ schema also. There is no employee table. Let's switch database. Let's go to public schema. In public schema, there are no objects. We say create this table and insert data. So I'm creating employees table. Before that, let's use raw underscore db dot raw underscore schema. Then create this table. Then insert this data. Then now create a secure view. So I'm creating secure view. So view employee names successfully created. Now I am querying this secure view. So we got employee name and department names. Now let's see difference between these three views. First important data storage. Standard views, no storage. Materialized views, first query, it will get results and results are going to store into materialized views. Secure views are similar to standard views, no storage. And coming to performance, standard views query computed at runtime. So every query executes every request of a standard view executes select query on base table. So little slower. Coming to materialized view, first time it will execute query and stores the results. Next time onwards, it will return results from materialized view storage. So it is faster. Coming to secure views are similar to standard views. So for every query backend, it will execute for every request of secure view or from client, it will execute select query and base tables. And security wise, no added, no additional security in standard view. Similar to materialized view also no additional security. Coming to security view, hides hides underlying data. Means it hides SQL logic, it hides underlying base table, so that user cannot know from which logic we applied on this secure view and which table it is connecting. So for normal queries, use cases, for normal or simple queries, we go with standard views. If you want performance and optimization, we go with materialized views. If you want to secure your data, then go with secured view stream. These are main differences between standard views, materialized views, and secure view stream. So clear writing these three types of views. Yeah. Now let's continue master Snowflake. In this, let's continue stored procedures in Snowflake team. Till now, we've seen SQL statements. We return multiple SQL statements in SQL worksheet. Instead of writing multiple SQL statements, instead of executing multiple statement individually, my requirement is I want to write a group of SQL statements to perform a particular task. So we have stored procedures. Stored procedures are like a functions. In this stored procedures, uh, we can write uh, we can write group of SQL statements, related SQL statements to perform a particular task or action. And all the statements we write in a procedure are related statements to perform particular action. Okay, here implement we can implement stored procedures with programmatic implementations like control flow statements. And the advantage of these stored procedures are reusable. We can write a stored procedure one time. We can call that stored procedure any number of times wherever we require. And other advantage is we can divide large problem into smaller problems. Each problem we can develop using stored procedures, and we can reuse all these problems in main function or main call. So modularity, dividing large problem into smaller problems and implement different procedures. So basic syntax of procedure is we use create or replace procedure, procedure name, and then every procedure returns value. So we have to return what is the value we are returning. Then we can specify the type of that value. Then which language we are using to implement this stored procedure. It supports SQL, it supports Python. So you can provide which language you are using to implement stored procedure team. And then here we start a stored procedure with begin statement. Then we write SQL statements and we end stored procedure using end statement and dollar symbols. So these two are very, very important. Starts with dollar and begin. Then we write one or more SQL statements. Then we end stored procedure using end and a dollar symbol. Let's start implementing. Yeah. Start off stored procedure. Yeah. Let's start one stored procedure. In this, we are writing insert logic. Insert logic. One minute. Yeah. Here I'm writing one stored procedure. Uh, Using this stored procedure, I want to insert data into table. So in this, first I'm creating one table called customers using create command. So this create command we perform only one time. Then insert we may do multiple times. So here what I'm doing, I am creating one, let me create SQL file. Let me give SQL file name, stored procedures. Then here let's use this database to use raw underscore db and raw underscore schema. Now I am creating customers table. In this customer table, I want to insert the data. So to insert the data, I am writing one stored procedure. So first I am writing stored procedure definition. Stored procedure definition tip. So create or replace insert customers. A stored procedure take 0 or more arguments. You can specify how many arguments you are taking. Then once this stored procedure successfully completed, we are returning some message to the caller who calls this stored procedure. We are returning message in a string form. Then I am implementing this stored procedure using SQL language. Then start of stored procedure. Then here I am writing insert into customers and whatever parameters we are receiving, right? I am passing this first name, last name, and email ID and values. So whatever values we taken as a parameters, I'm using colon that parameter values. Then finally, I'm returning message saying customer inserted successfully message to the caller of the stored function. Let me select the stored procedure. Let's execute. So function insert customers created successfully. So stored procedure definition completed. Now call a stored procedure. So I am calling stored procedure, call stored procedures. Then here I am writing call insert underscore customer. I am passing parameters to this stored procedure. This stored procedure expecting three parameters, first name, last name, and email ID. So same parameters I am passing to stored procedure. So let me select this query. Let's execute. So stored procedure is executed successfully. It is return message saying customers inserted successfully. Then I'm writing select query to find whether record is inserted successfully or not. So it is inserted. So customer ID, customer first name, last name, and email ID, and created data. If you see in create table query, customer ID, I set up auto increment and I said it is a primary key. So this auto increment started customer ID 1. For next record, it will increase customer ID. I used auto increment key. It will generate keys dynamically into this customer ID column. And coming to created at, I used timestamp. Default, I used current timestamp. So if you see here, it is created current timestamp value into this created data. So here I said this column is a default column. If you not insert a value into this created at, it will generate current timestamp and loads that value into created at column. Because of auto increment, because of default values, we are seeing customer ID, we are seeing created at with current date and time. Clear writing this stored procedure. First we are creating stored procedure. Next we are calling this stored procedure. Yeah. Return type is optional. If not return value, it will return default value empty. Yes, yes. Because stored procedure syntax is return type should be presented. If not return any value, it will return default value empty. Yes. Yeah. Let me implement another stored procedure. In this stored procedure, I'm going to work with multiple tables. So here I am creating two tables. One is orders and other one is order logs. I am writing stored procedure. Using this stored procedure, I want to insert data into these two tables. Let me implement it. The first one, I am creating orders table. Then I am creating another table called order logs. Then I am creating stored procedure. Yeah, I created two tables. First, I created orders table. Next, I created order logs table. Now, let's create a stored procedure. Observe, I am creating create or replace procedure, insert underscore order and log, and I'm taking parameters and returns value string. Then I'm implementing this using SQL language and stored procedure start. Here I'm writing insert query to insert data into orders table, insert data into orders log table, and finally I'm returning message order and log inserted successfully. Then end of stored procedure. Let's execute this stored procedure logically. Let me select the stored procedure. Click on create stored procedure. Now let's call this stored procedure to pass values. Call insert and log stored procedure. Then again I'm calling same procedure to insert another records. Then I'm executing select query to display orders table and to display order logs table. So here in stored procedure, we can write one SQL statement, we can write multiple SQL statements. Depends upon our requirement, we can write one or more SQL statements inside a stored procedure. Yeah. So let's discuss one real-time use case. Use case purposes automate data archival process. Scenario is a company needs to archive old data. Example, transactions older than 6 months. They want to move to, uh, they want to archive table and delete it from the main table. So here what we are doing, we are creating two tables, one table transaction table and other table archive underscore transactions. So here our requirement is if for transactions older than 6 months, older than 6 months, we want to delete from this table, we want to move it to another table called archive transactions. So I am creating two tables first. I am creating two tables. Let me create transaction table, then create archive transactions table. Then let's write insert data into transaction table, insert data into transaction table. Okay. So I'm inserting four records to four records. So four records are inserted. So current to date, if we compare these transactions, all these transactions are more than 6 months compared to current data. Then we want to write a stored procedure. That stored procedure should check transactions every record and it should check transaction date and check with the current date and check if transaction happened greater than 6 months, then move this record to archive underscore transactions table. So here, if any transaction more than 6 months, we are archiving transactions from main table to archive underscore transactions table. So let me write a stored procedure. So in this stored procedure, I'm writing that logic. Let's observe stored procedure. So first, create or replace procedure, archive old transactions. Here, no parameters. Parameters are optional. Returns string. Language we use to implement this transaction procedure is SQL. And start of procedure. Then here I am writing insert into archive underscore transactions, transaction ID, customer ID, amount, transaction date by selecting transaction ID, customer ID, amount, transaction date from transactions, where transaction underscore date less than or equal to date underscore add and month minus 6 from current date. Okay, so transaction date, I'm checking whether it is. So from current to date, we are minusing 6 months. Then we will get a one date, right? Then I'm checking transaction date less than or equal to this 6 months date. So we are minusing current to date. Then we are checking transaction date less than or equal to this date. If it is, then we are selecting that data. We are inserting into transaction table, archive underscore transaction table. Then finally, we are writing delete command to delete that greater than 6 months data from transaction table. And finally, we are writing message saying old transactions are archived successfully. Let me execute this procedure. Then let's call this procedure, call archive old transactions. Let me execute this one, control enter. Now let's execute select queries on both the tables. First I'm executing select star from transactions, then archive underscore transactions. See, no records are presented. Now let's execute archive underscore transactions. You can see all transactions are greater than 6 months. Then all transactions are moved to archive underscore transactions.